Today we're going to concentrate on multiplying and dividing integers as well as multiplying and dividing terms. All right, let's lay out the basic ground rules for you. I think a lot of you have probably seen these before. A positive times a positive is a positive, and a negative times a negative is also a positive. And if you multiply a positive times a negative, you're going to get a negative. And because of the commutative property of multiplication, we know that a negative times a positive will also give us a negative as well. Okay, so let's apply this with some problems here. So here we're multiplying and dividing some integers. We can look right at these, and the first thing we should be able to determine is whether our answer is going to be positive or negative very quickly. Okay, in A, we have a negative times a negative, which is a positive. In B, we have a negative times a positive, which is a negative. In C, now the same thing works with division, because division and multiplication, although they're opposites, they're very similar operations. I can turn any multiplication problem into a division problem, like 12 times 1/3 is the same as 12 divided by 3. So negative divided by a negative is a positive, and lastly, a negative divided by a positive is a negative. Now we can just go through and treat these integers like they're whole numbers. 12 times 3 is 36. 12 times 3 is 36. 12 divided by 3 is 4. And 12 divided by 3 is 4. Okay. The positive signs really aren't necessary, but I'm using them here to kind of illustrate to you that you can determine whether an answer is positive or negative before you actually multiply and divide. All right, now exponents falls into the category of multiplication because exponents are just simply repeated multiplication. So on E, we've got -6 times -6. That's a negative times a negative, so our answer is positive. 6 times 6 is 3. On F, this is -1 times -1. That's a negative times a negative, so our answer is positive. And 1 times 1 is 1. On G, we've got -3 times -3 times -3. Okay, so if you have 3 negatives, just like I said, a negative times a positive is negative. 3 negatives is also negative. Think of this as 9 right here. -3 times -3 is +9. Then you're doing +9 times a -3. You've got a positive times a negative. So anytime you have an odd number of exponents, you're going to find that the answer does come out. I'm sorry, anytime you have an odd exponent and your base is negative, you're going to find that the answer comes out negative. So this is -27. And then -2 to the 4th power is -2 times -2 times -2 times -2. Okay. We could look at this as +4 times +4. You got a negative times a negative, which is positive, and you got another negative times a negative, which is positive. So we're just doing a positive times a positive. So our answer is +16. Okay, so exponents are just repeated multiplication. So watch those exponents, and really the only time you really got to focus on whether the answer is negative or positive is when your base is negative, and all these have negative bases. -6, -1, -3, -2. All right, so let's solve this equation. X squared equals 100. We've done some of this a little bit with the quadratic formula. I'm sorry, not the quadratic formula, but the Pythagorean theorem. Sorry, I'm a little ahead of myself. The Pythagorean theorem. Here are the solutions to that equation. Do you know what number squared is 10 or 100? If you said 10, you're only half right. There's actually 2 solutions to this equation. Because -10 squared is 100, and 10 squared is also 100. So this is actually an equation that's got 2 solutions. then let's see, what are the square roots of 100? So if somebody asks you the square roots of 100, just like up here, you'd say that the square roots of 100 are negative 10 and 10. Okay, but if someone asks you the question in this form, what is the square root of 100? You know, I've just shown you two instances where we're giving two answers, but actually in this equation or this expression, the square root of 100 is just 10. Okay, if I wanted the negative root of 100, I would put a negative sign out in front of this square root symbol. So a little bit of getting used to on this here, but on equations, we always give all the possible values of the variable that make the equation true. And in this case, both of these numbers make the equation true. If someone asked you what are the square roots of 100, you'd give both roots of 100, negative 10 and 10. But if someone proposed to you this expression, the square root of 100, you'd just say positive 10. Drilling for core samples in the seafloor, the driller used 12 drill rods and 8 meters long to reach from the surface of the ocean to the lowest core sample. Write an equation using integers that shows the depth of the core sample with respect to sea level. So I guess the way we're looking at this is if we write integers, we're going 12 drill rods and each going 8 meters deep equals negative 96. That is to say, just to illustrate this for you, 12 is the number of drill rods. Negative 8 is the meters below sea level that each drill rod reaches. And negative 96 is the total meters below sea level that all 12 drill rods will reach together. Okay, so there's an example of where we can use integers to express real-life situations. All right, so now we got some terms that we want to multiply. Okay, so we're not just doing negative 12 times 3 anymore like we did on one of the first examples. We're doing negative 12x y squared z times 3xy. Okay, so we've learned some rules of exponents, and now we know how to multiply integers. So let's apply all that together. Okay, first of all, negative 12 times 3 is negative 36. Okay, x times x, when you're multiplying numbers at the same base, you add their exponents, so 1 plus 1 is 2. X times x is x squared. Y squared times y is y to the third, and then we also have that z there too. So negative 12 xy squared z times 3xy is negative 36 x squared y cubed z. Let's do this again with division. Okay, negative 12 divided by 3 is negative 4. X divided by x is 1, so we don't need to write anything. Y squared divided by y is y. We know the rule that when we're subtracting or dividing numbers at the same base, we subtract their exponents. So we're doing 2 minus 1 is 1. We don't need to write those ones. And then we have a z. Okay, so just look at each variable. Negative 12 divided by 3 is negative 4. X divided by x is 1, so we don't need that 1. Y squared divided by y is y, and z becomes z. And we're done. We've simplified those expressions. Let's do this, some distributive property here. And we're also multiplying terms. So on this first one, we're going to do 2x times 2x, which is 2x times 2x. And then we're going to subtract 5 times 2x. Then we'll simplify each one of these. 2x times 2x is 4x squared, and negative 5 times 2x is negative 10x. On the second one, we're going to do 2x times negative 2x, and we're going to subtract 5 times negative 2x. 2x times negative 2x is negative 4x squared, and negative 5 times negative 2x is positive 10x. A negative times a negative is a positive, so instead of subtracting a negative, we're adding a positive. 5 times 2 is 10, and we also have this x right here. Okay, we can't do anything more with either one of these terms, or these expressions, excuse me, until we know what x is. Okay, so today we multiplied integers, and we also multiplied terms that involved integers. And we're going to practice this over the next several lessons before it shows up on a test. All right, we'll see you soon. Good luck.